So just as a quick review up in here, Jennifer received $9 for 2 hours of babysitting. At this rate, if she babysat for 27 hours last month, how much did she make? Well, we can look at three different methods for solving these. Three methods that we've already gone over. This first one is to make a model, right? And then up in here, let's say, well, we got the 2 hours that we split in half, so we'll split this one in half. And then we see that she made $4.50 for each of these two blocks right here. So we can see right there that she made $4.50 per hour. Well, that should help us to figure out how many or how much money she made for 27 hours, right? We'd multiply the $4.50 by 27. But in this next table right here, we can see, yes, that if we got 2 hours, we'd have to divide that by 2 to get the 1 right here. So also, we would divide the 9er by 2 as well, and we get the $4.50. So you can see kind of that these are already set up kind of as proportions for us. And we have hours in the numerator and the monies there in the bottom. So this next one, to solve it, we'd multiply the 1 by 27 to get 27. So $4.50 by 27, and that would give us our answer as well. All right, so $121.50, and that works pretty good. On the other hand, we can look at this table right here, and we can see down yonder that we got 2, 9 right here. And then if we scale this, multiplying them both by 4 would get 836, and multiplying that by 2 would get 1672. So, from here, of course, we can just continue this pattern until we get to 27, which would show 121.5. Now that's a little bit more difficult on the graph because of all the points. So there could be an easier way, and that's what we'll see if we can find right here. So we have used the equation to solve problems like this. Also, write an equation for this situation and explain how the equation can be used to solve the problem. So the equation that we had was $9 for 2 hours. And then this should equals some number of dollars, so we'd say X, for 27 hours. So this is still a principle of equality because what we want for equations was 1x, right? So to do that, I would multiply both sides by 27. 27 divided by 27 is 1x, which is what we want. And then I just got 27 times the 9ff, which is still $121.50 in dollars. Of course, don't forget your label on this. So this would be method 4, just using another principles of equality, which we've already done. That was unit 3, but since it was so stinking long ago, no one remembers any of that garbage. So, state the proportional constant in this situation and describe how we found it. We already did that, right? We did $9 for 2 hours, and the proportional constant was for 1 hour, and that was $4.50 for the 1 hour. So that's how we found it. We divided the 2 by 2 and then the 9 by 2 as well to get $4.50. So how many hours did Jennifer work if she earned $150? Well, hold on, let's look. So on this one, we'll set it up. Now we can use the unit rate on these. We can use $450 for 1 hour, or we could use the 9 and 2. It doesn't matter because it's still proportional. But right up in count, we got $150 for some number of hours, okay? Now we'll learn a different method to solve these types of problems. Of course, not everyone needs a different method for this, but we'll look at other methods to solve these later on. So the proportional constant is just where we want one of the values to be 1. Usually it's the denominator, but it doesn't matter. You're just dividing it by whatever that value is, the numerator specifically. So we could use that equation. Y divided by x equals 4.5 is a proportional relationship. That is the proportional constant as well. We've looked at that before, y over x. Each side of the equation is a ratio, y over x. So y to x is the ratio or money earned to hours worked. And 4.5 is the ratio of 4.5 to 1, or $4.5 to 1 hour. A proportion is an equation stating that two ratios are equivalent. So, for example, and I guess we looked at that later then, so we'll just look at that on the next part. But always be sure that we're consistent with the units of the quantities we're comparing. in the proportion below both quantities are comparing dollars to hours. So we got 9 over 2 dollars, $9 to 2 hours equals some number of dollars to 27 hours. Okay. So we wouldn't want to switch that and compare 27 hours to some number of dollars with $9 to 2 hours. That's not going to be proportional there. $9 is to 2 hours is how many D dollars is to 27 hours? Is this the only possible proportion for the question? Nope! We could set it up differently if we wanted to. We could just make this still a proportion, so we got two fraction lines and an equal sign. But we could flip them and make this 2 over 9 is equal to 27 over the number of dollars. We didn't use D though, we used X. Now, the nice thing about this is it doesn't matter if we flip the fractions, it's always going to give us the same answer either way on that, okay? So if you solve this proportion radical, you would still get that X would be $121.50. So what strategies can you use to solve the proportion? Well, here are the strategies that we've learned. So far, we have learned the principles of equality. Principles of, this would be good, equality. And then also, we have learned scale factors. Scale factors, and we'll talk more about those. The other two methods that we're going to learn, I guess you could say unit rates is another one, but it's kind of still scale factors. So the other two that we're going to be learning about are going to come later on in this lesson. So just hold on to that. There are two other methods. By the way, the nice thing about this unit is we give you all the garbage stuff in the beginning, and then we show you the really good stuff at the end. So most people prefer these other two methods over these three, for the most part, but not always. So let's look at the comparison of these. A proportion is kind of like this sandwich, radical, and then we slice it up and we put some lettuce in there, usually some mayo, some taco seasoning, a little peanut butter, right? Some sour cream, some black beans, and ketchup. Did I miss anything on that?
Bacon.
Well, this is a vegetarian sandwich, so. Anyways, you see, if I took this sandwich and I cut it in half, and then this portion right here would be 1/2 of that sandwich. Right there. Well, I did my best, right? Well, if I cut those parts in half, now if you have the same amount, then you would have 2 pieces out of the 4 pieces. See how that's equal? Right there. That's all we're saying in this, except for now, we're going to be taking out one of these values and you got to solve for that missing value. So 1/2 is the same as what over 4? 2. 2 over 4. Set up 2 proportions for each problem, and we'll look at a couple ways. We've already looked at a couple ways to do this proportion stuff, setting it up differently. Be sure to write your units for comparisons. You do not need to answer the question yet, so we may come back to these, and then we'll solve them then. But the first one has been done for us, which is extremely kind of them. Alright, so a 5-inch frog can leap 50 inches in one jump. If jumping distance is proportional to body length, which it's not, but if it were, how far could a 60-inch human be able to jump? Set up 2 possible proportions. So we can see on these that, see how they did body length divided by the jumping distance? So we got the frog's body, which is 5 inches, and the 50-inch jump, compared to the human 60-inch body divided by that unknown value, okay? But if we flip them and we compare jumping to body length here on the right, then we'd have 50 over 5 and G over 60. It's a different looking proportion, but it's going to give us the same answer. And it doesn't matter which way we set this up. So Eli won 2 out of 3 chess games in one day. At this rate, if he played 33 games, how many did he win? So let's look at the 2 comparisons on these. So we'll get to the answers later, right? We'll revisit these. But in the meantime, we've got games that he won, and then games that Eli played. So in comparison, we got this 2 fractions radical. Right there it says he won 2 out of 3 total games. But we want to know if he played 33, which would be the played games, how many would he win? So that's the setup. But remember, if we reciprocate these or flip them, then we have a different way to set this up, okay? So that would be a comparison of games played compared to games winded. And that give us, what is that? Oh, just flip. So we got 3 over 2, 3 games played, 2 games won, compared to 33 games played, and we don't know how many won.
I know how many.
Now again, we'll come back to these and then solve them later. So the next one, Eli won first place in a spelling contest. Millie won second place in the contest. They had to share a cash prize in the ratio of 8-5. Eli received $72. How much did Millie receive? So we've got first place, and we'll compare this to second place. But for the second set, we'll compare second place to first. And it doesn't matter which one of these you use. So we'll set these up. We got these proportions up in here. And we can see first place is going to win 8, while second place wins the 5, because second usually wins less. And Eli, who won first place, got $72. So we need to know how much Millie, who won second place, will receive. Now again, we'll write this again. Second place was 5. First place was 8. And first place was Eli, who won $72. So what's the difference between these two, the way both of these are set up? Well, here in the red, we got the x in the denominator. And here in the purple, we got the x in the numerator. So it means that you get to set it up the way that you want, so that the x is where you want it. But we'll see using the methods, the different methods, that it may not matter to you which or where they are. So Bargain Betty sells sneakers and scooters in the ratio of 3-8. The store sold 21 sneakers yesterday. How many scooters were sold? Okay, well, we got sneakers compared to scooters. Or we compare scooters to sneakers. And up in count, well, I guess we don't want the equal there. We'll set up a proportion these away, and then also these. And it says it's sneakers and scooters, which is the same as sneakers to scooters. So that's 3 sneakers to 8 scooters. And we're going to sell 21 sneakers. We just got to figure out how many scooters there are for the 21 sneakers. But it works the other way around. You can sell 8 scooters for 3 sneakers. And then we also got 21 sneakers, and we don't know how many scooters. So again, it depends on where you want the x, in the bottom or the top. In this next one, in 1.5 hours, a sprint race sled dog can run 30 miles. How long would it take the dog to run 12 miles? All right, so we got distance in miles compared to hours. Or we compare hours to miles. And then we got our proportions set up in here. Alright, so right off the bat it says that they can run 1.5 hours for 30 miles. And how long will it take them to run 12 miles? So that's in X hours. Or on the other hand, they can run for 1.5 hours and 30 miles. And we'll look at 12 miles. And we'll figure out the number of hours. Now notice we're not finding a unit rate on these ones like we have in the past, but we will. I just set on my desk, please. Thank you. But we will. We will be solving these even though we won't need the unit rate anymore. Finally, number 7, Bliss chocolates have 220 calories for 6 pieces. How many pieces should you eat if you wanted 150 calories of chocolate? Okay. Well, let's look at this. We got calories compared to pieces. Or we can compare pieces to calories. So we can set these up. And we'll just fill these in. So it's 220 calories for 6 pieces. And we want to know, we want to eat 150 calories. We just don't know how many pieces. But the same way with pieces, calories, we got 6 pieces for 220 calories. And we want to figure out how many pieces for 150 calories. We will revisit these after we learn the other 2 methods. Because so far we know how to solve these using principles of equality, which was from Unit 3. Or we can use scale factors, which is pretty much what we've been using this whole unit so far. Alright, number 8, an ant can crawl 3/4 of a yard in 1/2 a minute. So we got to compare this 2 different ways. We're going to compare yards to minutes, but we'll also compare the minutes to the yards. And it doesn't matter which way you set this up. Again, you get to choose, and then you get to solve using whichever method you like. So, on this one, we'll set up these 2 proportions. And up in here, it says it's 3/4 of a yard, so 3/4 of a yard for 1/2 of a minute. And then we got 12 yards for some number of minutes up in here. And we don't know what that value is, so we just got the X for now. We'll solve this later. The other way to set this up is just to flip the fractions, okay? So in other words, I got 1/2 a minute for 3/4 of a yard. But I also have 12 yards, and we just don't know the number of minutes for that yet. But we will, okay? Number 9, the side lengths of 2 triangles below are proportional. So these are proportional, which means we can set up a proportion to solve them, okay? Specifically, let's call this triangle A, and that triangle C. And we're going to compare triangle A to triangle C. And then in the fractions, we're going to compare the big side to the small side. But then we'll compare the small side to the big side. So we'll set up these proportions, and then we'll solve these later. So for triangle A, the big side is 7, the small side is 3. For triangle C, the big side is 10.5, and the small side is unknown. Well, for the next one, again, we're just reciprocating those, so the small side is 3 when the big side is 7 for triangle A. And then the big side is, hold on a second. Yeah, the small side on that one is unknown compared to the big one, which is 10.5. So this is the way both of these are set up. Again, we may notice from these 2 setups that either X is in the denominator, like this one, or X is in the numerator, like this one right here. Okay, so you just got to choose which way you like it, or which way where you want the X to be. Finally, Tim is on the basketball team. His ratio of shots made to shots attempted is 1:4. So we got 2 things we're comparing. We got shots made to shots attempted, but then we'll also compare shots attempted to shots made. So we'll have our 2 fractions that are equal for both of these. And right up in here, it says made to attempted was 1:4. And then if Tim attempts 40 shots, then we'll figure that out. Yeah.
It's 10, sir. Yeah.
All right, the next up, we got attempted shots to made shots. So 4 attempted to 1 made, and then we got 40 attempted to X made. It's exactly the same answer so that we can see that it doesn't matter how you set it up.
Okay,
You
now
still get the same answer.
he's fitting.